everyone. Welcome to Nokia's Cloud Packet Core Let's Talk Facts Roundtable. I'm Sharon McTurnan, Head of 5G Core Campaigns at Nokia, and I'll be your host for today. This event is going to be a little different from what we've seen before. We're not going to explain cloud-native networks or give you a long product advertisement. Instead, we want to talk facts about the packet core. Facts that can affect decisions service providers make when they move forward with 5G. 5G networks enable many new extraordinary services and revenue possibilities for CSPs. This requires a flexible, high-performing packet core to deliver low latency and high-speed connections those services demand. CSPs need a packet core that can be implemented on any cloud to take full advantage of the features provided by this architecture, like automation, security, artificial intelligence, and machine learning. For today's roundtable, I'm here at Nokia's Executive Experience Center in Dallas, and I have three Nokia guests connected remotely. Please welcome Keith Allan, Packet Core Product Manager, Marcelo Madruga, Head of Technology and Platforms and Core Networks, and Mike Hawley, Head of Packet Core Research and Development. If you have any questions during the event, please type it in the chat window. If we can't answer them live, we'll send you the answers later. So let's get started discussing the facts about 5G Packet Core, including deployments, performance, flexibility, openness, and proof points. Keith, I'd like to start with you. In your experience managing Nokia's Cloud Packet Core product set, what areas do you see are most important for your customers?
Well, hi Sharon, and it's a pleasure to be here with everyone today. First, it's a packet core network. So the basics are throughput and latency, and in today's packet core, you need high throughput and low latency. The demand for data rates continues to grow year after year, and with 5G, the radio access continues to grow, and the core must keep up with that, as well as new services, and making sure that we provide the right performance of the network where it's needed, when it's needed. Nokia has an advanced architecture design named Virtual Forwarding Path that allows the packet processing to happen in an optimal manner. The design allows distributing of individual packet flows from the same user entity device and process them parallel. And this allows the throughput per UE device to get to very high speeds of 10 gigabits per second or even higher. That's generally 3.5 times available higher than the other solutions available on the market today. And while it's providing that very high throughput, it's doing it with a complete set of high touch services, including deep packet inspection, firewalling, and network address translation. Another benefit of the single pass forwarding of the packet is low latencies. We can get that as low as 300 microseconds in forwarding, again with full services touched. And this enables a new set of services that are requiring low latency and is key to deliver on the 5G promise of ultra reliable, low latency communications. A second area that's very important to the CSP is that the network can be flexible and scalable and respond to the demands. Every network's unique. There's different geographies, different services that are supported on the network, different densities of users. Some are very rural, some are very metropolitan. And having a solution that can provide an optimal deployment in all those different locations is key. And that includes having very large central multi-terabit packet core user planes that can be in the downtown core or near major international data centers, as well as having solutions that you can put out further in the network or in smaller rural serving areas where you still want to keep the traffic local. And you can do that with things like integrated hardware, software, packet core appliances that allow you to quickly respond to the throughput need and minimize the latency wherever it's required to meet a diverse range of business needs.
What about the technologies like 2G, 3G, and 4G? How can CSPs connect to those?
Well, again, all the generations of wireless 2G, 3G, 4G are definitely required and required to be supported simultaneously on the network. However, in addition to that, there's new access technologies that are being integrated on the same network, such as wireline, fixed wireless access, etc., that the CSP needs a solution that can anchor both the wireless access from the typical user subscribers on mobile devices, as well as wireline access, whether that's on DSL, PON, or fiber, and make a universal adaptive core. And it can respond if the traffic shifts between the different types of access. And this leads to operational and cost optimizations.
So Mike, what about you? As head of Packet Core Research and Development, what new technologies are there and what is exciting on the horizon?
Hi, Sharon. Thank you. I'm glad to be here. I've recently spoken with customers and identified some of their common challenges. And the one I'd like to discuss today is how do you minimize 5G implementation risk? First, there's some new concepts introduced with 5G that greatly increase the flexibility and allow CSPs to be nimble, nimbleness being a key way of minimizing risk. So first, the concept of a cloud network has become more nuanced. There's a private cloud that a CSP builds for themselves. There's a public cloud, which is one that's built by a third party, also known as a hyperscaler, where the CSP is renting the hardware and software. There's an on-premise extension of the public cloud implementation. And finally, there's a hybrid cloud where more than one implementation mode is used. Second, the core network in 5G is architected following cloud-native principles with microservices that dynamically scale, automatically handle failure, and make it easy to add and remove components. Third, solutions must be hardware agnostic, free from vendor lock-in, and certified to be compatible with many or any cloud platforms. Being cloud native alone doesn't ensure that your software will run on any cloud. These three things give CSPs the flexibility to be nimble. As 5G core networks are being built, there's two major design requirements that have to be fulfilled. They have to be deployed regionally for coverage and also for low latency. And in 5G, that latency is even more important than it was in 4G, so that we can offer things like ultra-reliable, low-latency services. Now, these two things can lead to a significant investment in servers and in real estate, even though the subscriber load and the revenue at that point in time is very low. CSPs can minimize this risk by deploying on public cloud. In public cloud, they can take advantage of the wide geographic coverage offered by hyperscalers while only using and paying for a fraction of the cost of these resources and using OpEx instead of CapEx. In the early days of any technology, the demand for services can be quite unpredictable, with pockets of high demand like an enterprise or unexpected surges in demand, such as when a new device is introduced. In this case, public cloud capacity is used to serve the customer quickly while avoiding overbuilding capacity and underserving demand. If the end user demand remains, then you optimize later for the workload and the traffic.
Thank you, Mike. What an excellent explanation. Now let's take a minute for a quick poll and check the audience expectations for network deployments on public cloud. The question is, what percentage of networks will be deployed on public cloud during the next 5 years? More than 50% or less than 50%? What do you think? Please give us your answer using the thumbs up for more than 50% and the thinking face for less than 50%. Again, the question is, what percentage of networks will be deployed on public cloud during the next 5 years? More than 50% or less than 50%? All right, time's up. Thank you for voting. We will consolidate the results and put it in the chat in a little while. All right, let's move on. We have more facts to cover. So Marcelo, as head of technology and platforms, what are some of the important innovations coming up, and what direction are things moving towards?
Hi, Cheryl. Thank you. It's a pleasure to be here with you all today. Well, we are all looking for innovations and our CSP customers as well, and they would like us to help. So network innovations like advanced software architecture, cloud native, hyperscaling capabilities, and hardware agnostic design will improve the whole network performance and reliability, not only in packet core, but overall. However, the most important innovations are the ones that enable new services, so CSPs can profit from their investments. Shifting the core consumption model from a facility build to a software as a service is an innovation that drives CSP profit. Here, the network software will be operated by Nokia, hosted on public cloud, releasing CSPs from network operations activities like upgrades, expansions, and maintenance, so they can really focus on simplifying their network operations, exploring new opportunities, improve the end user experience, and increasing monetization. The second innovation I'd like to discuss is network slicing. CSPs are looking for more and more network intelligence, so they can fine-tune the network for end customer needs and preferences. In other words, it's not only applications and end customer devices, but also dynamic connectivity and configurations optimized per use case that will play a role in delivering the best customer experience.
Can you give us some more facts about the slices? What are the benefits for the CSPs?
Yeah, you can think of slice as a kind of a intelligent connectivity feature. It enables to build connectivity for a specific set of parameters like bandwidth and latency. So the slices can be custom designed to support many use cases and can be programmable for different services and revenue streams. However, as important as slice network slicing is, automation of slicing creation, configuration, management is extremely important. Configuring the thousands of variables across 5G core elements and then maintaining all those configurations quickly becomes too complex to do manually. Here, Nokia's network automation innovations enable reliable, repeatable, efficient, and fast deployment of these complex network slices. This kind of level automation is a game changer and allows CSPs to rapidly target and serve new customers, creating then new revenue streams for the CSPs.
Great, thank you. So Mike, what about the fact that CSPs need to optimize their expenditures on operations? What does Nokia recommend?
Well, in the context of packet core, the answer is network automation, and there's a couple dimensions of it. The first dimension is intrinsic automation. As Marcelo just mentioned, automation of slice creation, configuration, and management is extremely important. It comes from truly adopting web-scale practices. CSPs need to adopt cloud-native design principles to gain the same benefit as those web-scalers have in their networks. Another part of this is orchestration. Kubernetes is a web-scale orchestrator that can automate the lifecycle management of telco network functions in the same way as it does for any web-scale application. So you can grow and shrink the network as easily as you can with any web-scale application. But that is a fundamental shift in the way that CSPs need to think about the network. They need to think about the network as a collection of orchestrated and automated microservices instead of a collection of disjoint network elements. Now, the second dimension is the expansion of the DevOps concept into DevOps, which you can think of as CI/CD extended from hyperscalers environments to telecom. Now, DevOps was designed for CSP environments where the network is multi-vendor. The DevOps models used by many web companies are inherently single vendor, and they just don't work in a CSP's multi-vendor environment. So instead of a single software source, CSPs have multiple vendors and have to address integration across all of them while setting up pipes to ingest CI/CD deliveries from each one of those vendors individually. Nokia's Devops delivery operations addresses this challenge and brings true multi-vendor CI/CD agility to CSPs.
And the question that every CSP is considering at the moment, how to maximize profit from a 5G network. They need to profit. How do we support it, Marcelo?
We have already seen financial reports that show additional revenue coming from 5G premium services, and so significant increase of subscriber coming from users seeking 5G benefits. Moreover, services like fixed wireless access, autonomous car, long-distance medical assistant, and industrial controls are just the tip of the iceberg, because now we see services development gaining traction. But how has 5G technology contributed to the growth of this new services creation? Historically, API-based service has been challenging to implement when the network relies on telecom-specific hardware and proprietary interfaces. However, service-based architecture and cloud-native systems are now removing these roadblocks. Initiatives such as developers forums, SDKs, and API standardization projects are lending significant traction to new service development. These will multiply service possibilities, delivering important monetization growth in the near future.
And what are Nokia's initiatives?
To give even more traction to this moment on the market, at Nokia we have a new initiative to enable developers to create brand new service easily. It's called Network as Code. Advanced service chains like Uber are built on distributed as a service resources, and developers use integrated development environments to create meta services to put those services together in a chain. And the key point, through simple API calls. The key on Nokia's Network as Code initiative is extreme simplification. Why is needed? Because there's a huge number of APIs out there, and they are very complex in the telco network. So we need network capabilities abstraction. All these APIs goes through a secure network exposure gateway. Network as Code is a Nokia initiative that unlocks the network for developers and fosters openness to drive innovation and profit for communication service providers.
Thank you. Now let's check on the audience again with a second poll. This time I have a fact. Network as Code will bring extreme simplification. True or false? Please give us your answers using the buttons below on the video screen, plus a thumbs up for true and a thinking face for false. Again, the true or false question is, Network as Code will bring extreme simplification. What do you think? All right, time is up. Thank you for voting, and the answer is true. Network as Code will bring extreme simplification, and that's a fact. Let's move on. On another topic, something we see in the news nearly every day is network security. 5G networks must be very secure to keep up user information safe. Keith, how can we do this?
Well, security is critical to CSPs because their business success and reputation depends on delivering reliable, secure experiences to their customers. And that's becoming more critical every day and a key requirement for customers selecting their communication service providers. As the packet core evolves to support new services and deployment models, it increases the threat service for attacks. There's new services that have new access points at the end of the service delivery. There's new locations on the network where the service must be delivered. And for low latency applications, there's being the network expanded further and further out to the very far edge of the network to be as close as possible to the computing applications. And as well, there's services required out of region, and that's requiring service providers to deploy access to the services in locations that are not necessarily 100% within their control. And this presents some new challenges. Like mentioned before, any cloud implementation, and that changes the picture as well. There's different types of platforms to secure. Traditionally, telecom networks had closed proprietary hardware systems. But now as you evolve to cloud, you have to make sure that you're evolving security to have that same level of success and hardening. You have to make sure there's no way for it to be penetrated the same way your former closed hardware systems had in the past. The good news is that 3GPP standards put many safeguards in place with strong authorization of users, authentication of different network elements in the system between each other, as well as all sorts of secure communication techniques, encryption, and other technology to make sure it's very hard to impossible to create or duplicate a rogue network element in the network to achieve a different type of nefarious activity. And as a packet core vendor, though, it's critical that we start that at the initial packet design and take that hardening into every single level of the packet software and architecture.
And how are CSPs perceiving this need for security?
Well, they're asking their packet core vendors to adopt that culture security from the ground up. Security vulnerabilities that you hear about in the news often are day one issues, and so they have to be prevented from day one. From the very start of your product development process and design principles, you have to have a strict adherence to zero trust principles for any information coming in to your network element to make sure everything is confirmed and there's no false information or false attempts to take control. And so all the interfaces are fully secured and fully tested before they're ever deployed in the network. And this will ensure that issues aren't encountered in the field. As well, there's new techniques emerging like artificial intelligence, machine learning, that can be used to monitor the network and quickly detect intrusions or any other security event before they have a chance to cause damage. So if they're noticed, then that port or access can be quickly shut down before the person with access has any chance to have negative effects. And if you're constantly monitoring and validating everything on a real-time basis, then it'll enable you to mitigate those threats to your network. Nokia is an expert in telecommunications networking technologies, and we've been securing those CSP networks for a very long time. We continuously evolve that approach to make sure we include the same level of confidentiality, integrity, and security within our development environment that keeps up with the latest rapidly evolving technology.
Great, thank you. Now it's time to move on to some questions from our audience. We've got many questions coming in, so that's great. Thanks for participating. First question. There's big hype around the ultra-reliable, low-latency connections. But what about the real applications for this? Can you mention one example?
One thing I can mention is an example of teleprotection of high-voltage power lines. So this is real-time critical in protecting the power grid from any failures, as well as protecting the surrounding people and wildlife around those if there's ever a fault detection. For example, sometimes the system has to automatically cut the energy of a power line when it's damaged or severed, and that needs to happen before that power line hits the ground and causes sparks that could cause fires, including wildfires. And so that's something ultra-reliable, low-latency communication is designed to do and is an important aspect of the 5G cloud packet core and edge equipment.
Great, thank you. The second question is about public clouds. How mature do you think this technology is, and how much can CSPs really rely on them for network deployment?
Hi, Sharon. I can take this one. This is a very good question, and I'm going to answer it with a fact. It's now public that Nokia's 5G cloud packet core is operating live on the Amazon public cloud, or AWS. That network is commercially launched and available today. And it was not easy to reach this point. It took a lot of effort from my R&D team. It took a lot of effort from many Nokia teams. There was a lot of iteration and figuring out how to get all these things to work to make a ultra reliable 5G cloud packet core. But we did it, and it's here, so we're ready to go.
Great, that's exciting stuff. We have time for one final question. You mentioned about network as code, network exposure function, and the importance of simplification. However, developers need to test environment. Will Nokia make that available?
I'll take this one, Cheryl, and I'll answer like Mike, with effect, and the answer is yes. There is an Open 5G Lab initiative that's already available for developers to test their application. I will ask someone to post the link on the chat window. There you can find all the information about using the lab for testing. But there's another initiative as well, which is not related to test environment, but I believe it's important to mention, the Open Ecosystem Network. It's focused on community building and has many interesting articles about APIs that can help developers encode their applications. I'll ask someone to post as well here.
So what a great discussion. We're coming to the end of our event today, and I'd like to wrap it up with some final thoughts from each one of our panelists. What are your top considerations when evaluating Cloud Packet Core? Keith, let's start with you.
Thanks, Sharon. It was a pleasure participating in this discussion today. As a final consideration, I want to mention that every network has its distinct attributes in terms of design, capacity, and access technologies. So packet core deployment flexibility, especially when it comes to the far edge where appliances may have to be used because there's no cloud resources available, adding new types of access to network like wireline is crucial when building a 5G network for maximum revenue potential.
Great. And Mike, what are your thoughts?
Thank you, Sharon. It was a great discussion today. My final consideration is that 5G packet core implementation risk can be minimized using public clouds. However, notice that just because software is cloud native does not mean that it can run in any public cloud. So make sure that you have field-proven network functions from your vendor.
Thank you. Marcelo, what's your final thoughts?
Yeah. Hi, Sharon. Yeah, it was a great discussion, great conversation. Thank you for inviting me and the others here. I want to reinforce that simplified operations innovations will bring significant OpEx optimization to CSPs. And at the same time, API abstraction, network as code, will speed up the development of new services that can be monetized.
So I'd like to thank all of our guests for being here today and spending some time giving us some great information. So that's our roundtable. Hope you had a great time and have learned from our experts about the facts you need to take into consideration when evaluating Cloud Packet Core. You're invited to explore more about Cloud Packet Core by clicking on the link you see on the screen and also in the chat window. Thank you for watching, and we'll see you again next time.